Okay, we are going to start limiting factor analysis. Limiting factor means what? Limiting factor means shortage of resources. Shortage of resources. Due to shortage of resources, a company is unable to maximize its demand. Limiting factor analysis basically are of three types in F5 syllabus. One, we are done throughput accounting. Second, we are done with the single limiting factor, which is based on machine hours or labor hours or material. And the third one is linear programming. So today, first of all, we will discuss linear programming. We are already done with the all types of short-term decisions. I recommended you a few sections to listen before the class. Although I am done with the review of short-term decisions, but I suggested to listen again from the recorded lectures and to see the question videos so that you will be able to understand short-term decisions and you are already done with the single limiting factor. So today our today's topic is linear programming. What is this linear programming? Linear programming basically says that a company is facing shortage of resources. That's why a company is unable to meet its maximum demand unable to meet its maximum demand and linear programming is the one where a company is facing two or more limiting factors. Although in our syllabus in F5, examiner will not ask more than two limiting factors. So examiner will ask maximum two limiting factors. Now linear programming has different dynamics or different topics which we are expected to discuss. First one is optimal production plan. Second one is shadow price. Third one is slack. So these are the things which we will discuss in the linear programming. Suppose we are going to assume data that a company is producing tables and chairs. Now, company says that we have or we need 2 square feet fabric for the chair and 1.90 fabric square feet. It is in fact square feet fabric for the table, and in total we have maximum 1980 square feet fabric. So this is what we have. Second one is wood. It says that
No, ছিল un
we need suppose 5 square feet wood for chairs, or we can say rather 7 square feet for chairs, and we need 4.95 square feet wood for table, and maximum we have 3490 square feet wood. These two equations are called limiting factors. Company is producing two products, tables and chairs, and these are their limiting factor equations, or we can call them constraint equations. This one is showing maximum availability. Further question says that maximum contribution of the chair is $8 and maximum contribution of the table is $9. Now we were expected to calculate optimal production plan. What would be the step number one? Step number one is denote appropriate alphabet for products. We have two products, chairs. We are denoting C for here. We have already used this word. Tables. Tables are denoted by T. Step 2, constraint equations. We have already shown constraint equations that 2C plus 1.9T is equal to 1980 fabric here, and 7C plus 4.95T is equal to 3490. Step 3 is calculate optimal production plan. Basically, step 3 is the one where we are solving a number of uh, values or calculating number of values. First one is, first sub step is allocate all resources to chairs. We are assuming that if we produce only chairs, what would be the maximum amount of chairs or what would be the maximum amount of contribution if we produce only chairs? So we say 2C plus. Now we are producing only chairs, that's why table will be 0 is equal to 1980 square feet. So C is equal to 1980 divided by 2. 990 chairs we can produce with the help of fabric. 7C plus 4.95, again T is 0, is equal to 3490. 3490 divided by 3490 divided by 7. Maximum here we can produce 498. Sorry, one thing I want to change in my data, which I think can create trouble for us. Rather than 1980, we will say it is 1180. Here, and once again here, and once again here. I am assuming it is 1180 rather 1980. So the second value is 498.57 and 1180 divided by 2 is 590. If my wood is not available, this equation is of representing fabric, it is representing wood. If my wood is not available after 498.57 units, then how can I produce 590 chairs with the help of fabric? So maximum I can produce what? Maximum I can produce the lower number where one of the material is now ended or no further availability of material. So maximum I can produce 498.57 chairs. Now I am assuming that I am allocating all the resources to tables. I am allocating all the resources to table. So 1180 divided by 2 I can produce 590 tables here. Table is equal to 3490 divided by 4.95, 705.05. Again, if my fabric is ended after the production of 590 tables, then how can my wood produce 705 tables? So the maximum tables we can produce is the lowest number, which is 590. This is where I allocated my all the resources to one product. But I am not sure that either here we have the maximum contribution or here we have the maximum contribution. We are not sure. We have to calculate. But now we will follow simultaneous equation. Anyone, any question?
So why did we divide 2 instead of 1.9?
1.9 is the usage of fabric. When I am producing tables only, then I will divide fabric availability by 1.9 and I will divide wood availability by 4.95.
If we divide 1.9, it will be 621 instead of 590.
Let me check once again. 1180 divided by 1.9. Sorry, I think I mistakenly divided by 2. Please correct everyone. It is 621.05. So we will correct over here as well. 621.05. Right? Anything else?
No, sir, thank you.
Okay, thanks. Now we will use the simultaneous equation. What does say it says? It says 2c plus 1.9 t is equal to 1980. 7c plus 4.95 t is equal to 3490. Now we will use simultaneous equation. Objective of the simultaneous equations to equate either value of c with each other or value of t with each other. So what will we need to do? We need a digit which will multiply with both the equations where either c value of c's will be equal to each other or value of t will be equal to each other. So rather than to put in too much effort and find out a variable or a digit where these values will be equal, simply multiply 7 with the above equation and 2 with this equation. So we say 7 into 2c plus 1.9t is equal to 1980. 2 into 7C plus 4.95T is equal to 3490. So after multiplication over here, it is 14C plus 1.9 into 7, 133T, sorry, 13.3T, 13.3T is equal to 7 into 1980, 13,860. 14C plus 9.9T, 2 into 34, 90, 6980. Now change the signs. This one is cancel out. With each other. Here we have 13.3 minus 9.9, 3.4 P 13,860 minus 6,980 6,880. So now we are producing tables. Two thousand 23.5. Okay, I'm done with it. In fact, it is 1180. I mistakenly wrote 1980. That's why I was concerned that there is something wrong with this calculation. It is 1180. So 7 into 1180, 8260. Yes, it makes sense. Minus 6980. It is 1280. Now 1280 divided by 3.4, it is 376.47. Before moving further, I would like to tell you that from where I trace that I did something wrong. Maybe you are doing exams and you are also making the same mistake. Then how will you trace that where is something wrong? In fact, here answer was 2023 point something. Assume it was 2023. I look at this value of 1980 and I was saying that if I produce tables 2023, my available is total 1180. How can I even produce this number of tables? with this availability of material. And similarly, if I multiply 2.2 2023 with 4.95, it is more than this. How can I produce this amount of table with this amount of available inventory? So it means there is something wrong. Wrong was what? I wrote 1980. In fact, it is 1180. So as we found our mistake. Now we have the correct value 8260 over here and the correct difference 1280 over here. So we can say that we will produce 376.47 tables. Now I want to calculate how many chairs I can produce. If I put this table data in my first equation where 1.9 is needed to produce one table and simultaneous equation says that you should produce 376.47 tables and total availability of the fabric is 1180. So 2C is equal to 1180 minus it is 715.29. So this answer of this value is 715.29. So after deducting from 1180, remaining is 464.71 divided by 2. So maximum chairs we can produce 232.35. If I am going to put the same number of tables in the second equation, my answer of chairs must be same. Maybe there will be a difference of decimals, but in totality my answer must be same. So 7C plus 4.95 into tables are done 376.47 7 is equal to 3490. So C is equal 7C is equal to 3490 minus 376.47 minus 1863.35 1626.65 3490 minus 1863.35. It is 1863.52 almost 52. So deduct from 3490, you will get 1626.47 divided by 7, 232.35. You can see same number. So either of the equation will give you what? Will give you the same amount of units. We are done with the same amount of units. It means we are done with the maximum amount of chairs with the help of simultaneous equation. Now we are required to calculate in step number 4 maximum contribution We assume 8C plus 9T maximum contribution is equal to. Now there are different answers. In the first stance, we were only producing chairs, only chairs. In our second workings, we are producing only tables. Third one is simultaneous equation. So only chairs. $498.57. 498.57. Only tables 376.47. 8 into chairs are 232.35 plus 9 into tables are 376.47 and here we have only tables were how much if we produce only tables 621.05 621.05 if we produce only tables 621.05. Now 8 into 498.57 3988.56 maximum contribution if we produce only chairs. If we produce only tables, maximum is 5589.45. And if we follow the simultaneous equation, 8 into 232.35, it is 1858.8 plus 9 into 343, 76.47 0.23. So the total is 5247.03. Let me check the figures again. Either I put the right figures or not. This one is chairs value. Either we follow the this equation and the other one, and this one is 376.47. And initially we determined the maximum contribution 8C plus 9T. So maximum contribution did not came with the simultaneous equation. It is 5247. Maximum contribution came up with this value, where we are saying that 5589.45. This is not something which is not possible, but we should recheck if we are in the actual question exams that either we pick the right value, yes, we pick the right value, that lowest number can be produced maximum amount of units, or we will divide again 1180 by 1.9, we found the right value. Why I am saying that you should recheck, because normally maximum contribution will come from simultaneous equation. But again, I am saying normally, not always, because at times you will find an MCQ or a question OTQ where maximum contribution can come from either of the products. So here it is coming from where? It is coming from the tables. Now, after these calculations, the next most important, a very important question is how to draw these values in the graph. So here we will draw the graph. Although in the actual exams you are not expected to draw graph. In the actual exams you are basically expected to calculate values if needed. Calculate values of the graph if needed. Whenever we are drawing graph, we need two values, or we have two axes. One is called what? One is called y-axis. I will try to draw the straight line. And the other one is called x-axis. This is called x-axis. This is called y-axis. I am sure that you have seen CVP analysis videos and you are done with the questions. There we have graph as well. Now it is not necessary to show either of the product always on x-axis and the other on the y-axis. It is up to you. It is your choice. Suppose we are going to show the tables on the x-axis. We are going to show chairs on the y-axis. And we always need a time and again we have to visit these values to see the values. Maximum chairs we can produce 590, although we picked that 498.57. So we are going to draw points over here, and maximum number came R with the table, which was 705. So we are going to draw, I will say that 7 points, like 100, 200, 300, 400, 500, 600, 700. And here 100, 2, 3, 4, 5, 6, 7. First equation is this, where we allocate all the resources to chairs. C is 597 with this equation, fabric. And from fabric we have values of 621 of the tables. So for chairs, this is almost 590, this point, and this one is almost 621 for the tables. So we will draw a line. We will draw a line which will start from 590 and it will intersect with, or it will connect itself with 621. I am trying to draw a straight line from 590 to 621. Yes, this is the point. And it came from 2C plus 1.9T is equal to 1180. These are the lines of this equation. Other equation is can produce maximum 498 chairs and 705.05 tables. Okay, we draw our points maximum till 700. So we will add one more point of 800. If we are adding over here, we will add here too, although not needed in the chairs. So it is 705.25, like little greater than this 700. Oh yes. Here my line, here I am representing 705.5 and this point was 621.05 and here 498.57. So this is the almost 498.57. So first I will draw this line again, a straight line connecting with the 621. Now 498 will connect with the 705. Okay. This line is the equation of 2C plus 1.9T, and this second line is the equation of 7C plus 4.95T is equal to 3490, I think. 3490. Now we will draw another line which is units of the simultaneous equation. And we have how many units of the simultaneous equation? We have 376.47 tables and 232.35 chairs. So 376.47 tables and 232 point something chairs, 0.35. Now we will draw this line. This line is called usually ISO contribution line. Usually. In this question, it is not, because simultaneous equation is not giving the maximum contribution. Here we will say that this is O point, this is A point, this one is B point, this intersection is the C point, this one is the D point, and this one is E point. And this whole area is called what? It is called feasible region. Feasible region is called maximum contribution area. And maximum contribution will come from where? It is 705.0. Sorry, it will come from 621.05 units of the table. And 621 is marked over here. This one is the point of the 621. It is intersecting with what? It is intersecting with this equation of fabric at this point. So this is called the graph. Now I am going to assume one thing, that I am going to draw a straight line at a level of 500. Straight line. I am erasing this data and trying to draw the straight line at 500. What is the meaning of this straight line at 500 of tables? It shows maximum demand of tables is 500. This is straight line. Suppose I draw a straight line over here at the 400 level of chairs. So what is the meaning of this line? Maximum demand of chairs is 400. So although you are not required to draw the graph in actual exams, but you are required or expected to explain if graph is provided in the actual exams, or maybe with the help of graphs you are required to calculate different values and then provide your interpretation if question is asked in section C, or provide calculate values if question is asked in section A or B. So this one is the basics of the linear programming, in which we discussed what? We discussed a complete question, complete data, along with the graph. And one thing we discussed over here, what? This is the if demand is restricted up to a certain level.